All right. Here we are. Hello and welcome to the third installment of XR Circle. This time we're going to focus on a new topic. We're going to focus on the topic of optimization in virtual reality. And I think, with the rise of mobile VR sort of being now like the main platform or the target platform with the Oculus Quest and headsets like that, I think this topic has only become more important with time rather than less. And I'm really lucky to have two awesome colleagues with me here today. Usually we have invited guests from outside, but this time it's my friends from Canada that are joining me. I have Steffen. He's a senior software engineer here, so code all day and like a bit of a real-time applications expert.
Yes.
Of course.
Yeah.
And Mike, senior artist here at Canada, and a very inventive guy that has done a lot to improve our workflows and have come up with all sorts of crazy ideas for how to make stuff look good and run in VR.
Yeah, it's a fun challenge.
So I thought, who better to ask than these two guys? So it's actually really excited and feel lucky that you are up for doing it. We're changing the format a bit. We've tried something new every time in XR Circle, and this time we're trying like a webinar style. So that means we have like our little panel here. So I have my experts, and then we have recorded two talks from Steffen and Mike. What we're going to do is we're going to play those talks, and then I have the guys here. So any thoughts or questions or curiosities you might have, we're actually going to be able to just ask them and figure it out. So just to get you familiar, if it's your first time in Livestorm, we have the chat, and I see a couple of guys typing. Please feel free to use the chat. I'm monitoring it. I have Carrie and Morten from Canada here as well. They're also monitoring it. So we're keeping track and trying to keep up with what you guys have on your mind. There is another tab. It might be hidden in more, but there is a questions tab. So if you have any questions along the way, you can ask it there. And I think you are also able to sort of vote on it, and we will be able to track it more easily. So, you could maybe ask a question here. Does a bear shit in the woods? That's a common question, right? And maybe you guys can help me answer that later.
I would hope so. Just as long as there's no cocaine out there. Cocaine better.
So, all right.
Yeah.
A good beginning.
Oh yes,
Great beginning. Yeah.
So anyway, we'll come back to these questions. We have a segment for Q&A at the end, where we get to talk more in depth. But I think for now, let's just get into it. We're gonna see a talk from Steffen about the optimization aspects from hardware and software perspective for VR, and I hope you'll enjoy it.
Hello and welcome to this small talk on developing efficient real-time software for mobile devices. We're gonna look at a couple of different steps on our journey, and we'll start with the hardware differences between the mobile and the higher devices. We'll go into some main loop optimizations that you normally wouldn't do for maybe higher end device software and real-time software, but it's usually a real good idea on mobile devices. Let's talk about a bit about how to order the memory and order your materials and assets so that they're optimized and the GPU has an easier time of actually rendering stuff. Let's talk about some general good practices for real-time software that maybe have been lost to history a bit. And let's talk about creating illusions instead of a lot of code, which is all sometimes easier, and we'll summarize in the end. Let's dive right in. The big differences are mainly just the size of the hardware and the power of the hardware, but other than that, the mobile devices usually have a shared memory chip between the processing units, even if it has a separate hardware acceleration unit. They usually share the memory. It's also mostly battery-driven. The Oculus Quest 2, for example, is battery-driven, mobile phones, tablets and stuff, which really limits and throttles the CPU a lot. You also, as a software developer, have a lot less memory to actually build upon, so you have less wiggle room when it comes to trading off CPU and memory for whatever you need. And usually most devices today use between 2 to 6 watts, and there are iPads that use more, but this is usually the limit. And that's not interesting in itself, but compared to something like a high-end PC, where you have between 50 and 250 watt usage, depending, of course, on your GPU and hardware, but that sort of gives an idea about the range difference. Higher-end devices also have a dedicated memory per processing unit. That means even if you have a graphics acceleration processing unit with GPU, it has its own memory, which is structured in a way so that all the stuff that has to be drawn to screen is much faster. It's usually also plugged in, so you have no image or no problem actually with the power consumption, and you have a lot more memory to build your apps on. And usually most systems today have between 16 to 64 gigabytes of memory, and you can just ask the OS for more if you need it. If you're only building an app that has 2 gigabytes, you can just ask the OS for more, and it will give you more happily. So there's a lot of more wiggle room in high end that makes sense, but just to give you an idea. Let's talk a little bit about how this memory works and why it's important to keep in mind. And there are some differences between how you render stuff when you have unified memory or shared memory and dedicated memory per processing unit. One, for example, could be that on the mobile device, if you want to render something in a 3D world, you usually what you do on a shared memory device is that you tell the GPU, okay, now I want to render something, and then the GPU just allocates the partitioned CPU or the integrated graphics, basically just says, okay, here's the slot that's unused, just upload to that, and you can do that. You just split it from one section of the memory to the other. Whereas on a high-end PC or high-end device, usually what you do is you tell the GPU, lock, because I want to upload something. The GPU gets the signal and finishes what it does. It locks and readies itself for an upload of whatever assets or textures you want to upload. It then uploads. That takes a very little amount of time, but it's still much more than just splitting a memory. And then when the CPU is done uploading everything, you basically tell the GPU to unlock, and then it runs parallel with the CPU. So that there's a lot. When you actually get to the lock, you want to upload as much as possible, which means that batching stuff on a CPU is sometimes much more important than it is on a small mobile device, because it doesn't have as many threads, but you can upload stuff to it quite quickly. So the difference would be that on a high-end device, you would batch everything you could to make as few draw calls as possible, and you want to make as big textures as you want, as you can, 4K, 8K textures. Whereas on a mobile device, you would probably limit it to a top 1K or 2K textures, and then upload them more often. That would be the difference. Let's look at some main loop optimizations that's really important to think about when it comes to mobile devices, and that is they have a very limited amount of CPU and memory, but usually it's a good idea to actually trade off some memory to not do very heavy calculations every update loop, for example. It will also mean the same thing would mean actually moving over to more event-based logic, so you don't have to calculate everything or listen for everything all the time. If you have 1,000 scripts that listen for change every single time, that would be a bad way of doing it. What would be a good way of doing it is to make some singular scripts that listens or manages the changes and then sends events out when anything changes. If you have a lot of stuff, let's say, for example, if you're building a very complex you want to build a zombie game that you have maybe 1,000 or 2,000 or 3,000 zombies in the scene at a time. That's really gonna be limited using OOP schemes and architecture and way of updating every script all the time. You need to think about something like ECS or DOTS, which is again taking advantage of the caches and the memory and the way things are structured, and we're going to talk a little bit more about that in a moment. But it's usually not a very nice thing, because we as developers we are sort of getting used to object-oriented programming, where you can structure stuff, structure our classes and stuff in the exact way we want, and we have things organized in the way our minds sort of like to think about stuff. But it's really not very efficient for the CPU to update stuff like this, and let's talk a little bit about that in a moment. But let's go over to memory and ordering. Let's talk a little bit more about it. For example, limiting your textures and materials in a scene. It's usually we have especially if we come from a developer only or not so much an artist background. We have the idea that we can basically just make as many materials as we want, and they'll be fine. That's the worst way of doing it. Usually, what you want to do in these cases when you don't have a lot of memory to do with is make very few materials that all the assets and all the geometry in the world uses. So they will be making like color trim, color sheet, color trim materials where you basically move the UVs around to reuse a lot of the parts of the material and textures that you have already. It will also mean object pooling a lot more. So don't create and destroy a lot of objects all the time. If you're gonna destroy 1,000 zombies all the time and then reinstantiate them to have 3,000 zombies in the scene, don't destroy them. Deactivate them and reinitialize them another place, so you don't get so much garbage collection and stuff. It'll also mean don't build bigger scenes in third-party software. Try and reuse the models and the assets that you can as much as possible, and then build them in your engine, be it Unreal or Unity or whatever you use. That's usually a much better way, because then you can also do stuff like material instancing on your shaders and stuff. That's much more efficient than uploading stuff all the time to the GPU. So that makes a big difference if you get that down. So look up how to do good workflows of building models and stuff. That's going to be very important for you. Let's talk a little bit about these caches and the general good practicing for writing efficient code. And one of these things is, we talked a little bit about ECS and why that's much faster than updating stuff the old way by going into every single component and calling the update on that or whatever. The reason for this is predictability for the stack and for the caches. And usually what happens is that when you have a CPU, these CPUs have a cache they have 3 levels, where the L1 cache, usually that's called L1, is closest to the CPU, and the ALU, the unit that actually does all the logarithmics and stuff. And it's much, much, much easier and faster if you don't change the footprint of the L caches all the time. So the reason ECS and DOTS are much, much more efficient than object-oriented programming update patterns are that they can predict the footprint for every struct. So if you have 1,000 structs that's maybe called zombie or zombie weapon or something like that, it can basically filter over all of those, and then the exact same memory footprint would be for every single one of these structures, and then the CPU can update all of these 100-fold faster sometimes. That's a big difference. In general, this is also true with object-oriented programming. So there are tricks that you can do to sort of keep your code much faster, but I'll come back to that. I'll give an example later. Usually it's a very good idea not to use link as well, because link allocates a lot of memory. It's a functional pattern, so it creates a new list every time, or a new IEnumerable or something like that every time, a new collection every time, and then modifies that. So if you do that a lot of times in an update loop, that's usually a very bad idea. Use structs more often, and that's the same point as before. Structs are put directly on the stack instead of being pointers to somewhere in memory. So that's usually much more performant to execute in your update loops. Choose the correct containers. Lists are not the best for everything, and dictionaries are not always golden. If you have to loop over a dictionary all the time, then it's a bad container, of course. Clean up your own objects when you're done with them. If you know that there's a lot of the big group of the zombies that are gonna separate out from the scene now and they're not gonna be used, or if you move a bit away from a big part of the terrain and you're not gonna load it in for a while, do clean it up. It may be self-explanatory, but I see it a lot of times that people don't do that. But let's look at an example of structuring your code in so that they actually are put on the stack. And here you see basically I have two for loops, and I have three classes that have an int and a float and a C-long. These two for loops do exactly the same thing. They basically add all the variables together and puts them into the C class C's sum long in the end. And the difference between it is the first one actually loads it onto the stack, so it saves the variables in the for loop every time, in the outer for loop every time, so that the inner for loop can basically predict I have all these on the stack now. I'm gonna do the same with them every time. And the lower one just dereferences the class every time. And the problem with this is that the stack can't actually predict where these variables should lie on the caches. And it seems like a problem that would have been solved by 2023, but it's still not. This is, if you look at the debug console log, it's actually around 3.5 or a little bit less than 3.5 times faster, which is a lot, especially if you're doing stuff that's more complex with this. Let's say it's maybe it's square root or tangent calculations or something like that in your main loop. And if you have a lot of them and a lot of entities, then it's going to be a problem. Or actors or game objects or components that does stuff. And let's talk about stuff that's outside of the scope of programming, but a good thing to think about when you're building your projects, and that's faking it. If you actually don't need 4,000 zombies in the scene, or you can't see them in the scene anyway at all times, don't plan to have 4,000 zombies or 3,000 zombies. Plan to have the amount that you can have. And if you don't need physics, if you really don't need physics on each of these zombies, don't implement it. Animate a death animation or do something else, because it's usually not needed. And these requirements usually comes from stakeholders and third party and designers and stuff like that that think it could be cool. But usually you can get around a lot of these effects by cheating or doing it easier and much more computationally efficient. And usually complex AI, whenever I hear a CEO or some stakeholders say, we need some AI for this. We need it to be able to learn and all this stuff. Usually what they mean is that we want something that can change over time and that can often be done much, much more easily than implementing neural networks and complex AI in any sort of way. So think about that. If you actually really need it, of course, then think about it, but usually you don't. Let's summarize a little bit. On our main loops, avoid dereferencing too much. That's a general rule. Load the functions into the start of or load the variables of the data you actually need for the function into the start, so it can reside on the stack, and the CPU can figure out how to put it on the caches a lot easier. Avoid memory allocations and cleanup in update loops, and never use link. That's a no-go. Especially in update loops. Functional programming is not very good for real-time software. Save as many calculations as possible to memory. That's trading off a lot of memory. That might be everything from light maps to any midway calculations in an update loop that you can save to struct or anything else. And order your assets in a good way so you have more performance. You have full performance from the hardware, and that's usually making master materials that all your different assets use basically one material, for example. That's a very good workflow to have. I've done it a couple of times. overstepping your memory limits on these mobile devices is usually not a good idea. The iPads, for example, will just shut down. It just crashes the app. If you overstep your memory limit, the Quest 2 you'll basically, the OS will give you more memory, but it will take memory from the processes in the background that's actually tracking where you are in the world. So suddenly your performance and your experience will decrease exponentially. So keep within the recommended memory limits of the hardware. That's a very good idea. Be creative and fake whatever is possible. That's a very good way to go usually. Thank you.
All right. Welcome back. And let's give a virtual round of applause to Steffen. I'm going to do that now.
Oh, no.
The React tab. Here you go.
Wonderful.
Yeah.
Okay.
Steffen will be very happy to see this. Oops, I accidentally gave you a crying eyes emoji, but I think that's okay.
Thank you.
So that was some really good stuff. Again, we'll come back to questions in a bit. We'll have the Q&A session right after this. But first, we're gonna listen to Mike's talk as well, which I think ties very neatly into some of the concepts that we've heard from Steffen about sort of object pooling and thinking about memory and consolidating your things. And I think Mike will have a very sort of a practical approach to that from the art perspective and some sort of philosophy around how to approach this. And again, if you do have any questions, feel free to put them in the chat or put them in the questions tab, and we're able to pick them up right after this. Hope you enjoy.
Cool. So, how to think about real-time optimization? I feel like a lot of people treat optimization as something to do at the end of a project, or it's some kind of like something to do. And I feel like if people treated it more as a holistic approach or something to be taken into account throughout the whole project, then it would save a lot of time and save a lot of headaches later down the line. So, explaining how to think, because I think this is a really big deal, honestly. Real-time optimization is not a linear scale. We can't just move a slider and make things run better at the cost of like visual quality. It doesn't quite work like that. At least it shouldn't. Different techniques are needed depending on the context, and there are a bunch of techniques which we'll get into. These techniques are often sacrifice one aspect of performance for another. What I'm getting at with all this is that there's a lot of context here and a lot of potential ways of doing this, and it really depends on what you're doing, how you're doing it, what the context of the scene is, and so on. So it's better to be kind of loose and open as how you solve optimization issues than to be kind of rigid and like, oh, it has to be like this, or don't be too dogmatic with it, basically. So, defining the context. This is the most important thing, and it's the foundation of optimizing your project. Optimizing your project begins at the planning stage. Understanding the target hardware and user perspective is the foundation of optimization. It should inform your entire pipeline. So for this project, or rather for this presentation, I should say, the target hardware is going to be the Quest 2, and the user perspective is going to be VR, first-person perspective. I've got some 2 images there of like Doom and League of Legends, and I just kind of wanted to talk about the screen space, because this is really what is being rendered. And this is what you should really focus on, is at least from the 3D art point of view. The amount of screen space an object takes should be kind of informing you on how much complexity should be in that object. For example, in FPSs, the guns or the whatever you're holding in your hands, they take up a lot of screen space. They're very close to the screen as well, so it's justified to give them a lot of resources. Likewise, with something like League of Legends, the characters are often scaled up quite a bit more compared to their surroundings, and they often take a bit more screen space because you need to know what they're doing. They have to be expressive and animated, and so they are arguably more important than everything else. And then the landscapes themselves will be a bit more sparse because they're trying you're trying to render a lot of like area in a single screen space, and it's just thinking about it in this way, I think, is a much healthier way than obsessing over like poly counts and tri counts. Shader complexity and all that kind of stuff, but we will get into that as well, so don't worry about that. So what should I focus on? There's a lot to cover, but I'm going to break it down into these separate things. So scene layout and complexity, batch count, shader complexity, geometry complexity, culling and engine tools, discipline and taking care of yourself, basically, because it can get kind of crazy sometimes. But again, this is all focusing on the Quest 2, but I think you might be able to use some of this for other contexts too if you need to. So let's start with the scene layout and scene complexity. So on the left there, we've got some images from a blog about the level design study of the Last of Us franchise. And it's how Naughty Dog basically plan their levels, block them out, and really test with them as they go. A good scene layout can make or break the performance, to put it that simply. Like, what I'm getting at there is if you have like a long corridor or like a big open space with everything in it, everything's being rendered at the same time, it really limits your ability to optimize that later down the line. You can use LODs and things, sure, but things like occlusion culling go right out the window. And also, it's kind of not that interesting to just have everything like lumped in the same place. It's much better for the user to be able to explore and check things out. So level designers often use something called doglegging to limit the amount of assets rendered in a single frame, but it's, to be honest, I'm using that as from the optimization point of view. They also use it to make it more interesting to navigate the scenes. Verticality is another thing that is often used these days where not everything is on the same plane, but actually is broken up. Sometimes you may need to like look up or travel up or down, or something's below you, above you. It's just a more interesting layout, which also feeds into good optimized locations because you can limit what the player sees. And then identifying complex assets and placing them in a lighter setting is extremely important and will save many headaches later. You don't want to have the really expensive hero piece surrounded by a lot of noise and a lot of stuff because aesthetically speaking it gets busy, and then also from optimizing you have to deal with a lot more stuff. So yeah, this is optimization, but also encourages a really good layout and design. I think a level designer would look at this from the other way around, but there we go. So here's an example from our own Lift user course about inefficient scene layout. So here we have this room. It's a big open room with a bunch of elevators in there. The elevators are interacted with the heavy objects because there's a lot of interaction, lots of separate parts, and the user basically spends a lot of time working with them. And then on the left there, we've got that entryway coming from the cylindrical building, and then we've got an entryway at the bottom. And from both of those vantage points, you can actually see basically everything, more or less. And that's quite bad for the real-time performance. Ideally, what you want to do is block line of sight as much as you can. We did actually do a few things here to the scene to aid us a little bit. I don't know if you can quite see it, but between like the big blast doors and the main room, there's like a little like wall that comes out just to block line of sight. It's a hacky solution, but it kind of works. It doesn't help on the other side though that you can walk in and immediately just see everything. So this is a good example of what not to do. I think we'll definitely be taking notes for the future. But ironically, here is an efficient scene layout from the exact same level. So basically here we have some doglegging, as you can see, and a nice broken up scene layout. And it's just an example of what we mean by breaking things up, not just for the visual side of things and keeping things interesting, but from a performance point of view. Because if you're standing in any of the entryways, it's very difficult to see everything all at the same time. The information is spread out, the layout is spread out, so you can navigate this space without having to render everything at the same time. And it's just generally just much easier to deal with when it comes to implementing optimization techniques later. So with that in mind, let's talk about batch count. So batch count and draw calls, I'm going to use these words interchangeably. There is a difference, and in a nutshell, it's a batch count is a bunch of draw calls, but not quite. You can look into it yourself if you want more detailed explanation, but generally speaking, we just use the words interchangeably. Everything that's loaded into your scene is a draw call. That is geometry, materials, textures, and that's really important to know because your device can only handle so many of these calls per frame. And remember, it's not just your 3D model. Your asset is composed of many different elements, each requiring a separate draw call. And this varies depending on exactly what it is. But for example, a material can have lots of separate textures, which can be a draw call each. So by the time you get to your model, it's like your model is one draw call, and then you've got your material, which could be another, and then textures, it really adds up quickly. So clever use of materials, object batching, and instancing can significantly reduce the number of batches. One example, I'll just use the boxes there. So if you were to group all those objects together, that's one draw call. But if they were all separate objects, then each one is a draw call. So think about it like that. And that's why we batch stuff together to reduce the draw calls. The batch count on Quest 2 is kind of important because we've noticed that the performance will start to really tank when you approach 200. Ideally, the fewer batch count, or rather, the fewer batches, the better. Be clever with your materials because these tend to add up very quickly. Each separate material is potentially a separate batch. Even with things like GPU instancing enabled, if you have lots of materials in your scene, that can still really add up quite quickly. Identifying common areas of your scene and batch them together, that's obviously super important. You just basically want to be as smart as possible with how you separate your objects because things can get out of hand real quickly. In regards to materials themselves, try and be creative with your materials. Don't just have one material for one object. If you can reuse materials across many objects, try your best to do that. In certain game styles, like more stylized stuff, what tends to happen is that they'll have like an atlas for their base texture, and this can be used to map details onto many different things. Sometimes it's just a simple thing like a color swatch or like a color gradient swatch, and that way you can, create very varied things with very little resource usage. I think like sort of like Eastern games, like anime games especially, they utilize this quite well. And in Unity, UV1 is actually utilized for light mapping. I highly recommend making your own custom light map UVs, by the way, because there's a lot of tools now, especially for Blender, that can make this a lot easier. And you just generally end up with a much more higher quality result after baking. But also, if you create a nicely uniformed, normalized UV set for these light maps, you can then use them potentially for something like a detail map, like a tileable texture. If you were to create a custom material or a custom shader that utilize this, so for example, you take the color from the UV0 and then you blend it with like a tileable in UV1, then suddenly you've got a lot more interesting detail for very little extra cost. And if you wanted to go a step further, you could add another UV set and add some details on there. While it's not recommended to add like hundreds of UV sets, obviously, having like 3 or 4 UV sets on an object isn't as unperformant as you might think. It's actually fine. So try and be creative, see what you can do. It's always a lot of fun to try and get as much as you can out of something. And it's very satisfying when you have like a whole scene, for example, being rendered through a single shader. This is pretty cool. So here's a little example of what I'm talking about. So on the left there, we have 6 boxes, and each color is a separate material. So like a yellow material, a red material, and so on. And basically, you can see that all those 6 objects together is 28 batches. These are all separate objects, all with separate materials. And then on the right-hand side, you have separate boxes still. We haven't batched the models together. But what we've done instead is we have one single material for all of them. That is, part of the base texture has like yellow, red, blue, and so on. And you can see the batch count difference, 28 batches versus 9. And if you were to extrapolate that to like a whole scene, then the savings become kind of crazy, to be honest. So you can see, hopefully, how much you can save in terms of batch count just by being smart with your materials. We do our best here at Canda to limit the amount of materials we use as much as possible. So we've come up with some clever solutions based on that. So, shader complexity. As for the shader themselves, so transparency is a real performance killer due to the blending operations. So try and limit the amount of things like glass you have if you can help it. If you need things like decals, then try and find clever solutions to avoid using transparency, or use lightweight transparent shaders such as cutout if you absolutely have to do that. And remember that having a single semi-complex shader doing most of the work is better than having lots of individual shaders. As I say, it's just because the system can only handle so much being drawn at the same time. And the longer it takes, or rather, the more things that need to be drawn, then the longer the frame takes to render. So fewer batches means fewer things being drawn, which means a faster frame time. And for VR, that's really essential that you hit that 72 frames per second. So for amplifying shader graph, you can make your own stuff, and that's totally fine. I really encourage people to be creative with their materials. Just be aware that certain things like depth, especially depth calculations, are very expensive on VR, and it kind of is a bit funky because of the camera point of view. So things like like water, stylized water with that kind of depth effect, you probably don't want to do that because it's going to be very expensive to run on VR. Things like vertex displacement you can actually do, but just try and limit it as much as you can. And remember that excessive texture sampling is a real performance hog. So having that one material doing everything it's fine to have a bunch of texture sampling going on in there, but try and avoid having lots of materials with a lot of texture sampling going on. It just all adds up and slows things down. Most of this is basically just common sense. Just remember that your budget is a lot more unforgiving on mobile VR devices. So hitting that 72 frame rate is really essential on Quest 2. Otherwise, things start getting a bit nauseous. So let's talk about geometry complexity real quick. So try count is not a valuable metric for gauging the complexity of models. And by the way, this is all really important because I feel like a lot of people, when they think of optimizing art assets, especially 3D models, they immediately go for like, what's the try count? Get the try count down. And there's an element of truth to that, but actually it's a bit more complicated. So vert count is more accurate, but covers a wide range of stuff. So there's the vertex geometry, there's the vertex UVs, vertex normals, and the vertex color and alpha, and maybe some of the stuff as well if you've got like bone weights and so on, but I won't go into that. But basically, how we construct our models will have an impact on the overall vertex count. Annoyingly, the true vertex count is not often shown in 3D software. And what I mean by that is often it'll show the vertex geometry count as opposed to vertex UVs. So for example, if you have like a hard edge, then the amount of verts on that hard edge is actually higher than if it was just smooth. But also the bounds of like a UV island, those are all like points, extra points, and so on. And the vertex normals also add to the cost and so on. Basically, we'll get into this in a bit more detail now. But here we have some examples of some cubes with the vert count on there. So this is mainly to do with shading, but I'll go into a bit more detail with like UVing and stuff as well. So on the first cube, it's your standard cube from Blender with hard edges. The second one is the same cube, but fully smoothed. And then the last cube is just a fully smoothed cube with beveled edges. And the numbers underneath is the actual vert count of these objects. So the first one has 48 points, the second one has 8, and the last one has 24. So why is this? Basically, whenever there's a hard edge, the GPU renders it, or rather, thinks about it as if it's two separate objects. So you have like the flat plane on the front, then you have the flat plane on the top, and each one of those is 4 points. So it's 4 points, 4 points, and then 4 points, 4 points, 4 points, and then when you add that all up, it's 48. The difference with the 8-point version is that it's basically, because it's smoothed, it doesn't consider it as like separate. It doesn't calculate it in the same way. So basically, it's just 8 points. It's just 1 point, 1 point, 1 point. And it's using the same technique for the last one. It's just because it's beveled, the shading is like kind of controlled using the topology. So it's you get that kind of smoother edge. And with UVs, basically, whenever you have a UV island, the seams of the UV island behave the same way as the hard edge you see here. So it's having to kind of figure that out in the same way, if that makes sense. Maybe that isn't super well explained, but we can always go into that a bit later if we need to. And just because I mentioned bevels there, I just want to talk quickly about small triangles and LODs. So small triangles that are smaller than a pixel usually cause major headaches for the renderer and should be avoided where possible. So this is actually one of the reasons for using LODs. Not only do LODs reduce the poly count, obviously, but avoiding small triangles at a distance can really save you a lot of performance. It's basically gone into more detail in the post at the bottom. I'll get to that in a second, but just be aware that LODs are useful, but they do cost extra memory or batch cost when using them. So it's really one of these situations where, like, if you have a bit of extra memory that you can use to save on the real runtime performance, then you should probably use LODs, especially if you've got a real problem with like small triangles and things like that. The same is true, by the way, for bitmaps on textures, so just bear that in mind, that they can really increase the cost of a texture. And as I said, there's a really good post on that website there that I really highly recommend you check out if you're interested in this, because I feel like it's really overlooked sometimes on how like bad the performance can get pixel small triangles. But yeah, I'll let you look into that. So, culling and engine tools. Unity has some useful features to help you troubleshoot performance issues. Occlusion culling is a great way to quickly improve performance, but it is highly dependent on a good scene layout and design. So what I mean by that is you can set objects to occlude, and then anything set to be occludees behind it will not be rendered whenever like the camera goes across it. So obviously, if you have nothing to occlude the occludees, then nothing's going to happen. So that's why having doglegging and line of sight blockers and that kind of stuff is important in this context because it really lets you get a lot out of the occlusion culling system. And then if all else fails, there's also the frame debugger and profiler tools in Unity itself, which is great for finding the values of your scene. But just remember that it's on your PC and not on the headset. I always recommend testing on the headset as much as you can because otherwise, you'll end up in situations where maybe you add a really high poly asset or like a really advanced asset, I should say. And if you don't test it at the time, then you don't know what kind of impact that's having. And if you test much later and there's a lot of slowdown, it takes a lot longer to figure out what's going on, basically. But at least the frame debugger will help you figure these things out. It's fine for checking the number of batches, slow shaders, overdraw, and so on, but the true performance can only be tested on the device, and that's really important. There's no point being theoretically correct if the practical side of things is really slow or whatever. So there's a lot we've just talked about, obviously, so let's just kind of rewind a bit and go over the whole thing in a very bullet point form. So first of all, establish the target platform and user perspective to create the proper context. Once you have the context, tailor your pipelines and processes to the limitations of your context. So for example, a render-friendly art style or production method. And then create render-friendly scenes to avoid doing too much in a single frame and work with your designers, obviously. Set up your high-level optimization systems early, such as occlusion culling. I really recommend doing this because then it's there and you're encouraged more to then test, and you should be testing often. As much as you can, so that if something bad happens, you know when it happens. And then if all else fails, you can use the profilers and debugging tools to identify problem areas. Consider which objects should be batched, culled, or optimized. Be disciplined and collaborate with your colleagues. So as an artist, especially, you should respect the limitations. Artists can sometimes feel as though optimization gets in the way of a good-looking asset, but really a better mindset is to make something visually impressive within the constraints of the canvas. And remember, everything looks bad when the performance is poor. Not like being in VR when it's like 20 frames per second. And work together. So collaborate with designers on creating fun and engaging spaces that also respect the hardware limitations. And you should work with engineers to find performance solutions. I think, honestly, you'd be surprised at what kind of cool ideas you can come up with together when everyone is kind of aware of each other's problems or considerations. It's really quite fun. So in summary, there's a lot to keep track of, but by being informed of the hardware capabilities and setting up a pipeline that funnels you into the performant asset creation, much of this can be solved via good processes. Remember, optimization is not a formula. Every context will require a slightly different approach, and use the tools you have to find the correct solution. Most of all, just try not to be too restricted. Try and stay loose, and if you feel like something isn't going to work early on in the process, definitely raise it and talk to people. No matter what level you're at, just let them know. So yeah, thank you. If there'll be any more clarifications needed, I'll be happy to answer any questions.
All right, we're back. Good stuff. Thanks, Mike, for recording the talk, and thanks to both of you for being here now.
No worries.
So I figure we'll go into the Q&A segment now.
Mm-hmm.
I hope you guys online enjoyed it. I think we should maybe start by giving Mike also a virtual round of applause.
Oh,
and
thank
real,
you. I'm sure it's great. I can't hear anything.
Jonathan Müller on the chat said, delete the default cube.
I mean, if you do that, Blender's going to get sad, and then you've got other problems. No, it doesn't matter, but yeah, of course.
Jonathan, do you know the hotkey to delete the default cube in Blender?
It's not Alt F4, by the way, if anyone wants to be a smartass.
Jonathan says A plus X. Is that correct? Can you verify?
Yeah, do.
Great. Very
I
good.
use a bunch of custom hotkeys, though, because I'm a boring person.
So, on the subject of the graphics optimization,
Yes.
we also have a question from Christian, who asks, how do you prioritize mesh combining versus occlusion culling? We find that as we combine meshes to reduce draw calls, the meshes naturally grow larger visually and are more rarely culled.
Yeah, so that's a really, really good question. This is why you need to be kind of in the scene and finding out, from the perspective of the user, where the cutoff point is. For example, it is basically the case that, if you combine too many things together, the object gets very heavy, and then when it is drawn, then suddenly it's you have to deal with all this stuff. If you've set up a room, for example, let's say you have you're looking through a doorway down a corridor, and you've got a doorway at the end, and behind the doorway you've got a bunch of assets, maybe some just to keep it simple, some boxes. Obviously, when you're in the room and you're standing in the doorway, then you're going to be able to see all the boxes together. And so if you're only going to be in the doorway, it makes sense to combine stuff together from that perspective. But obviously, you've got that corridor to come towards the object, and so you're going to see those initial boxes all the way down the corridor, for example. Even though I just spoke about not having corridors and things, but we'll ignore that for a second. But what I would do in that case is that just split up the boxes in front of you that you can see from a distance. So then you can also load those independently too if you need to, and then have everything else as one thing, because in that way you're kind of utilizing the best of occlusion culling by having the stuff that isn't grouped culled away, or that stuff will be grouped together. It's just culled together, if that makes sense. And then the stuff in the doorway or beyond the doorway, because it's visible, you'll have that as one group. It isn't, as I say, it's not as easy as just having one rule set for everything. This is why you really need to be in the context and in the user perspective and seeing where things kind of transition and where those transition points are, so that so that to make an informed decision about whether or not to use one thing or the other. And sometimes I will say it's actually just very difficult, and sometimes you just have to kind of bite the bullet and pick the lesser of two evils.
Right.
So don't get too hung up on things. Just pick the best choice at the time, basically, if you can. And if you're aware of reusing assets elsewhere, then bear that in mind. Maybe that's a bit of context you need to be aware of. But yeah, don't get too hung up on it. It's just in the end you just have to pick something.
Yeah, that there's a general rule, right? That maybe stuff that are close together is good to combine into one mesh, but in anything that's all over the place, don't combine that. That would be the anti-pattern of combining meshes. Yeah,
right.
We see that a couple of times when we have big, let's say an industry or building where there's a lot of bolts in pillars or something like that. There's sometimes all these bolts get put into one object throughout the scene, and that means that there's a lot of detail that actually has a very big bounding box in the world, and that means that they will never be called at all.
And sometimes, actually, speaking of the bounding box, that can sometimes be a good starting point to see how much area of influence you could say something is taking. Yeah. And you can take that into account as a kind of starting point to say okay, well, maybe here it should be cut off, or working like that. Yes. Really. So
is there sort of a level design aspect to this as well, where you sort of one thing is you could try and find the right cutoff point, but maybe can you put a bend here in the corridor or whatever it is?
That's exactly so that's why good level design kind of can really save your ass in these cases, and that's why having big open spaces with everything in there can be a bit problematic sometimes. So definitely if you can make something a bit more interesting, or do it, because it'll help you.
Right.
But sometimes it can be really tricky, and I've got to say, in my time I've spent some time really thinking about how to solve some optimization problems. So it's not always easy, sadly.
Yeah. Right. Yeah. I hope that answers your question, Christian. Otherwise, you're typing in the chat, so maybe I can follow that up in a second. He says, yes, and thank you, ad hoc approach. Makes sense to me as well.
Yeah, for sure. I think the most important thing is don't get paralyzed by decision making. Just, it's better to make a decision than no decision.
Yeah.
About these things. So.
On the subject of decisions, this is maybe a question for you, Steffen, but maybe also a bit for both of you. Is that there's this saying in programming that premature optimization is the root of all evil. Where you end up sort of creating a bunch of problems for yourself because you optimize something that you didn't sort of have to optimize yet, and that sort of gets me wondering about on the one hand, I'm hearing you guys saying, well, it's good to have an approach where from the start I'm considering optimization, but on the other hand I'm hearing, well, don't optimize too early. And so where can I sort of, as a developer or an artist or someone working in game dev or VR, how can I think about that? When should I start integrating these thoughts into my process?
Also a very, very good question. I guess the problem is always time and money. So if we break that up into two sections, if you're doing research and you have all the time in the world to figure out some algorithm. You don't worry about the performance. But in the grand scheme of things, we're always working under some time constraint. And that means that it's always better to make an actual plan before you start. And knowing the scope and the context and the full range of what you need in a scene means that you really want to consider where you do the optimization. And let's say you have a level of and let's say I have a big level, and the level contains, at some point you're gonna make the AI for maybe 5 bosses or something like that, and you're only gonna have a handful of bosses in one scene at a time, so you don't spend too much time optimizing the AI for that boss. You're not gonna run 1,000 of them anyway. But if you know that you're gonna have, let's say you're gonna make a big voxel-based terrain generation system where you have tens of thousands of world points of voxels you need to run through every time, then you want to make the optimization and do the preparation for that system up front. And if you're writing for each loops and using link everywhere, and you know that you have to replace that at some point anyway, and you know that this struct that is very native to this voxel system or whatever, you're going to set a lot of values. Don't use the properties, because they'll mean that you actually call a function instead of just setting the value directly. So if you know all of these optimization tricks, and you know you're going to use it a lot, you spend a little bit of time writing it, doing the optimization up front, and then afterwards, of course, you need a role more. You need an iteration more of actually optimizing all these places. Get the algorithm to work, and then go in and optimize it a couple of times. That's usually the approach, we do.
I think as well, just to lean in on the art side of things, it's really important I would recommend following the whole white box, grey box final structure, so that you're not, rather, first of all, by white boxing everything, you have a really good understanding of the, what's going into the level, how big the level is, where some potential bottlenecks and problems are. And then when you grey box it, you can add more detail to that and really flesh it out more in a more semi-finalized context. The thing to bear in mind is, and this is kind of interesting, is it's much easier to down-res an object than it is to up-res an object. Because if you're, for example, if you've got a high poly object, if it's got a lot of cylinders, for example, you can reduce the cylinders while maintaining the shape, and you can cut things down. Whereas if you're trying to rebuild shapes and so on and add topology, you can kind of get a bit of wonkiness if you're trying to up-res it. But as Steffen was saying, like, time and money is kind of vital. So it's a question of how long you want to spend doing that. It's also a very tedious process. So if you can kind of hit that goal the first time by proper planning, then and reduce the amount of time you have to spend doing that, then
I think the white boxing is a good analogy on actually doing a preparation on a big algorithm, like making UML diagrams and actually doing the architecture a little bit beforehand and trying out different patterns and stuff like that. It seems like a kindergarten approach to building a level, but in the end it'll save you so much time, because you see the problems up front. And that's we spent time doing it here, even when we're under very much time pressure, because we know it in the end it's gonna save us a lot of trouble of fixing these stuff that we didn't foresee, these things that we didn't foresee. So
it's like, so am I understanding correctly? You're sort of thinking, well, what I want to do is I want to apply as much foresight as I have. I might not know everything that's going to happen, but I know we're going to need 5,000 of this guy in our scene, and we're going to have like one at a time of this guy in the scene. And so based on that, I can make some decisions about like how I want to approach it.
Yes. If you're having 5,000 of, let's say, a zombie or some creature, then you want to keep it very low poly.
Yes, ideally.
And you want to not do any sort of like material instance stuff on it, because that means they'll break it up. And then you also want to make an AI that can actually run, and even considering doing it in a Dutch style of manner, like I don't know what kinds of things we have across the line, but in Unity you have all these algorithms actually throwing it off, running the run or the update loop very very quickly by applying some Dutch techniques.
So in that sense, so there's one thing it's about like foresight and planning, and then the other thing is more about like system boundaries, or maybe sort of like initial design choices, where you say, okay, well, if I feel like there's a risk that I'm gonna run into problems with this, I'm gonna to try and choose a way of building it where I can at least tweak it later, and I
Yeah.
have the option to fix it and optimize it.
The worst case scenario would be that if the artist gets a list of creatures that he has to make, but he has no idea what amount of these creatures are going to appear in the level, he will make them equally detailed because that's what he's taught. And the same for the engineer. He'll make the AI approximately evenly weighted out, right? But in fact, that's the worst way of doing it, because it's very rare that you have a game where there's even amount of all creatures, of all assets. So if the designer and the planning team will sit down beforehand doing all this, the engineers and the artists will have a much easier time. Will save a lot of work in the end.
Yeah, I think just to chime in on this just very quickly. I think a more realistic scenario is that, say, for example, you make like a high poly boss creature who's like, this is the big bad. He's going to be huge and high poly. And then at some point in the process, a designer or somebody says, like, actually, we want this as like a regular enemy, and we want another boss monster. And suddenly someone uninformed might say, oh, just scale it down and we can use that as a regular enemy. It's like, that's a really high poly asset. Suddenly that's being used multiple times instead of just the one time. And that's why you've really got to speak up and say, like, no, we really need to look at this again, kind of thing, and redesign this or remodel it even.
Having 2 iterations of planning is better than having 100 iterations of programming and
exactly.
Trying to make things work under difficult circumstances.
Meetings suck, but they can sometimes be shorter than rebuilding things. So
yeah, definitely.
That actually leads me to another question, which is like, so Carrie is pointing to the PC. Is there questions for online?
Let's see.
Oh, yes, there is. Okay.
Yes.
Sorry. I want to prioritize
that's
Jonathan's
fine.
question.
Yeah.
How do you explain ad hoc optimization to non-technical people and stakeholders? I often encountered that they have no idea about best practices and find this ad hoc approach to be too technical.
That's a good question.
We do
face. Jonathan.
We face this a lot, actually.
I would recommend. I'd recommend reading up a little bit of metaphorics in like the techniques of actually speaking in metaphors. So let's say you have a very technical approach to something. I like to explain it. There's been a lot of different ways of speaking about these ad hoc optimizations and stuff. I hate when people say I'm writing code, because it sounds like a letter that you're starting in one end and you're finishing afterwards, and then you maybe read it through and that's it. But in reality, we're building much more complex dynamic stuff. So I like to speak about it as like an engine. So whenever people tell me don't spend any time doing it right and doing it, making good architecture up front, I'm basically telling me, if you tell me to do this, I'm basically mold casting the block of the engine block and everything in it. And that means that it'll be very hard afterwards to separate stuff out. But if you give me the time to actually design the engine proper, if a cylinder breaks or something, I can change it out one at a time, or I can actually change it out to different kinds of pieces of the engine. And suddenly, if you're speaking about buildings where you have a good foundation, or engines or ships or planes or something like that, something that these people, it might be POs or stakeholders or project managers, they might have a much better idea of actually, or what is it we're doing, and why is it not a good idea to cast an engine block or an entire car at one time.
I'll just say, from the more visual perspective, it helps obviously if your stakeholders or POs are interested in this stuff, and are willing to understand what's going on. One thing we actually encounter quite a lot as on the art team here is that we are sent CAD models. We work with CAD models a lot because we need to replicate real world objects that are engineered and manufactured. And sometimes we get questions like, why can't you just throw the CAD model into the headset and just use that? And
throw it in.
And it's the best analogy I can usually come up with is like, well, this is a very heavy object, and it's like trying to put a very heavy object into a very small boat. The boat's going to sink, basically.
That's a good metaphor.
And if you want to get technical, without being too technical, I mean, you could try and bring up the kind of resource element of this, in the sense that, a Quest 2, for example, can handle so much resources at one time. And then this object is like taking up most of that resource, for example, because it's got so many points on it. If you're able to do comparisons just showing them. I know the vert, I've just discussed how like the vert count isn't true in Blender and stuff, but it is a good indicator sometimes. And you could, if you know a CAD file is millions of polygons or whatever, you can just say like, well, the Quest 2 can handle like 1 million triangles in one frame maybe, and this thing is like double
10
that.
million.
Yeah, exactly.
Yeah.
I just try and convey that like also not just that, but the way it's rendered in STL files isn't necessarily a good thing for like. You know, VR viewing and also like real-time viewing because of like shading models and so on, and there are things you can do as well in that sense. Again, this is getting already pretty technical for these you know, people who are not in the know, and it isn't an easy thing to do. But I think the main thing is just really hold your ground and just really try and push for this, because especially at Canada we deal with a lot of companies who previously may have interacted with the visual.
Marketing.
Marketing. Who, you know, the focus is on offline rendering as opposed to real-time rendering. Yeah. And so they're just used to doing some cleanup maybe, but mostly just putting assets, you know, into rendering solutions.
Right.
And not worrying too much about, you know, how heavy they are. Whereas, you know, for us it's like the whole thing is like, how does it run? Like it's so.
The whole thing is like a mobile phone.
Yeah.
It has to work.
So that's been a big challenge for us, honestly. Like, is just conveying that. But just try and find ways to do it. I know it's not easy.
Be creative with your metaphors. That's the best advice I can get. I can give you.
I think that's nice advice. You know, try a metaphor, try a different language, and also, you know, highlighting the scarcity essentially. Like what you're saying. That was to your point, Mike. Is like we have $100, and we're about to spend $70 on this thing that you want. But we need to put in some time, so it's only 10 or whatever.
And I understand that time and money is a real limiting factor in this, because people, you know, just throw it into the headset. That's kind of semi-instant, as opposed to no, we need to remodel this in a simpler way. That takes a lot of hours, and but you need to say like, if we don't do this, it's basically not going to work. Like so.
I found that sometimes when stakeholders ask this stuff, just put it in. I just did it. Sometimes I'll show you why it doesn't work, and I just put in a big model of a very big engine on a ship or like a big ferry or something, and then they just saw that you know, the headset broke down and exploded. Just started heating up on their face, and then you know they know that next time they have to listen to you, because otherwise they'll just crash. You know, so.
Basically, all these talks, by the way, I think it boils down to the point of you don't want to be in a situation at the end of a project where you're getting like 10 frames per second on the headset and the delivery date is like next Monday or something, or Friday. Yeah. And it's like, oh God, what do we do? Like, you don't want to be in that situation, basically.
And the stakeholder's going to be asking you, like, why is it like this? Why did you do your job? Like, it's not working. Like, it's not good enough. So
that's why you really need to speak up. Like the sooner the better. If people aren't listening to you, then you need to just raise it and raise it and raise it. Until
and if they're making a very insane decision in your mind, fill out a piece of paper and make them put their name on it, where it says very clearly that you are they are now making a very bad decision, and you try to explain to them 10 times that this is a very bad decision. Then when they come afterwards in the end of the project and say, why is this not working, and then you can hold up the paper and say, this is why it's not working.
If it gets that bad,
you made this decision.
Steph, that's your I know you've done this. I don't know if you've done it here, but I know you've done it before. So.
I've never done it here, but I've done it before a couple of times.
Oh yes.
I have a question. Another question from Christian on the topic. You mentioned CAD models.
Yes.
And so he's asking any recommendations on third-party programs or other solutions for simplifying CAD or architectural models, at least semi-automatically. Is there such a thing, or is it you just gotta put in the work? So
there is one, and I'm going to be really horrible now and say I've forgotten the name because I barely use it, but it has been used. Pixis, thank you. Yes, Pixis. There is Pixis. It does a fairly good job.
Okay.
I personally...
it's very expensive.
It is expensive, and personally I feel like if you have a very good understanding of like modelling and topology and just the whole process, I think it is in the end more efficient just to kind of do it yourself most of the time. Not always. It depends on the time frame and the cost, risk, benefit stuff, you know. But I just feel like you get a much more scalable solution if you do it yourself, because then you have the opportunity then to do more with it. Also, I just tend to find that a mesh with a clean topology is a lot easier to work with than the triangulated nightmare fuel that comes out of these crunching up things sometimes. It's fine if you just have a quick project and you just need to do a proof of concept or, you know, something super quick, like just get it in, go. I understand, but if you're doing a long-term project, I really do recommend finding a way of rendering these CAD files in a more optimal way. Just because
What would the manual process be? Would that be, you know, exporting it as an STL and then importing it into something like Blender and then selecting the places you want to optimize? Selecting the objects? Or?
So that is one way of doing it. What I tend to do actually is just model over it, like trace over it. Because we have like a texture sheets that we use for like common details, and we'll actually build that up if we're starting a new project with existing stuff. We'll build up like a texture sheet. Because the thing is, initially it's quite a lot of work, but once you like kind of get going, you tend to find that when you've got the next object in with the same bolts and the same, because industry stuff tends to be quite standardized. You've already got that stuff on hand in like a library. So you can just like bam 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 bam, like just do it really quickly. Even if you're just copy and pasting like details across, it becomes quite quick.
Okay.
But this is kind of where, if you're in the luxurious position where people are willing to invest in the immediate now for the benefit later, which, let's be honest, is kind of rare. Then you can do that. Otherwise, you can also just like, one thing I do in Blender actually sometimes. First of all, you need to delete all the stuff you can't see, because CAD files tend to have a lot of that stuff. Once you've done that, if you've just got the exterior shell, you can just select all and then delete limited dissolve, I think it is, in the delete menu. And then that's a good starting point to retopologize things and reduce things, or like split things up. There's another one, selecting coplanar, because CAD files always have these faces with like holes in them. So what I tend to do is just like select a coplanar face and on the other side, then delete that, and then like delete the holes and then cover that up, because you don't really need like small holes and things for screws and bolts. Like it's just wasted geometry. And then also, this is very specific, I'm sorry, but like in Blender, the decimation modifier, if you set it to, there's like 3 options, and the last one I think is angle based. I could be wrong about that.
Might be true.
If you set that to 17 degrees, this is really particular. If you set that to 17 degrees, it's not a terrible result, and it's fairly okay, especially if you mix that with like a limited dissolve. You get
the decimate modifier has an option in it that you say that actually works.
Don't just use the decimate slider like 1 to 0. Actually use the angle based one, because you get a much cleaner result. And then it's obviously, this isn't going to do all the work for you either, but it's a good like kind of point to work with or work from.
So you're not going to spend $700 on pixels doing that.
Exactly. So it's a pain in the ass cleaning up CAD files. I sympathize, but once you've got it cleaned up and it's looking nice, it is really worth it. So
it's good to know. Something interesting that Jonathan highlights out is he seems to have some experience with it. He says they have some top level structures that has billions of triangles. And for something like that, I guess that makes sense. You have no choice.
You are not opening that in Blender.
But if you have billions of triangles, then you also need like industrial strength work machines that have over 128 gigabytes of RAM to open that stuff. And I guess you need real software to actually do that. And then you also might be in a business where there's money for that kind of stuff.
Yeah, exactly.
So
Oh, he says 512 gigabytes of RAM.
That's a lot of RAM.
We'll be dreaming about that tonight, won't we? We'll be thinking about it. 512 gigabytes of RAM.
What kind of CPU is he using then? Is that a Xeon processor or something like that?
What I will say, if you do have CAD files that is like running to billions. I mean, what we do even with like millions is just like we break it down into separate components. Say if we've got like a complex building-sized CAD file that we sometimes have, we'll separate like maybe the exterior hull, and then there'll be interior elements which can be kind of grouped together and then separated out.
Because we have done that for like bigger projects, like container ship projects, right?
And like wind turbines and things. So like we'll identify the common parts and definitely work with your stakeholders in this, because I think it's in their interest that they deliver something that you can actually work with, and just try and break things up and do your best. But it is time consuming, I will say. It's a time sink.
Okay, but that's a very good question.
Yes. One follow up from Jonathan. Now we're really getting into the nitty gritty of Blender decimating.
Okay.
How many parts do your model have when you decimate in Blender?
Parts. It depends what you mean by parts. Do you mean like separate objects, or like?
I'm going to see if I can open the chat.
Because basically, obviously you just need to know how to build the model, like in terms of like performance, how things are grouped together. If it's more about like poly count and so on, or try count, then that is a question only you can answer based on the context of what you're working with. The hardware and the perspective and so on, I think. But what I like about that particular option, decimating by angle, is because the other methods tend to just crunch things down regardless of context a lot of the time, whereas the angle-based one, you kind of still get some semblance of sanity from the result, for lack of a better word. Regardless of how much it's reducing it by, it's a good starting point at least to work from.
Okay.
In my opinion.
Sounds good. Yeah. So I think we're nearing the end, but I would like to ask a question from me, something I'm curious about.
Sure.
We talked a bit about planning and foresight, thinking about what kind of issues may arise, what kind of things may have to deal with. Do you have any advice for someone who's already let's say in a not so good place? Let's say I'm putting on my headset and I'm feeling pretty nauseous. I'm not feeling good. My frame rate is low. Like what are some of the easy wins? Like where can I start if that's where I am?
I think a great artist once told me the most powerful tool in any software is the delete key. So,
take stuff out.
Yeah. Like honestly, one thing that can be helpful is just start disabling things in the Unity viewport and just disabling a couple of key things, building out, seeing how the performance is, and just see how far you need to go before things start running nicely. And then it's not always going to identify things specifically. You've also got the frame debugger for that as well, and the listener. But start removing things, and then sometimes it can be that there's a particular object or there's something going on in terms of the layout that can really cause problems. If you have no optimization setup at all in Unity, like occlusion culling, start with that, because sometimes that is just a blanket quick thing you can do to bake, just to get an immediate gain in performance. And then don't forget to set your flags as well to occlude or occluder.
Set stuff that is static to static, and then try occlusion culling. I would say that you need to use the profiler. So you need to, if it's memory that's a problem, or if it's the CPU, if there's something in the code that's the problem, you can see that very quickly, and it'll show you also how much of that is graphics. So if the semaphore is waiting and there's a lot of graphics being rendered, then you need to go over and do the level layout and check out how many shaders and set pass calls and draw calls you have. There's every single headset today has a limit. I sort of Vive had a 600K try limit, right, and stuff like that. So you'll go in and figure out where you are standing on that, and then try and move on by shutting down separate objects. And if it's a gradual change, then but usually what I see in the coding aspect is that people they're getting lag spikes because of the memory cleanup, garbage collection stuff. So usually it's because they're newing lists or using link.
This is, by the way, this is like Steffen's pet peeve is about using link in update loops. And just a bit of context, I love link. It's like the best library ever. But I have to try and keep it out of our update
No,
loops.
it's fine. I think you use them fair, but there's you're a backend developer, and I know backend developers love functional programming, and that's fine. But it's usually not a good idea when you want to manage your memory and you want to avoid these lag spikes. And the normal PC you wouldn't feel it at all when you have these cleanup pulls, but you'll definitely feel it in a VR headset.
Right.
So it's very important. You'll probably, if you have the timeline and you see the profiler, you'll see if there's lag spikes once in a while, and you can click them and see how much, how many milliseconds am I experiencing. And if you can I know that Unreal has a deep profiler as well, so you can enable the deep profiler and actually see, okay, I'm making 10,000 calls to this property. Do I actually need to make this many calls to this property, or can I change it out with just a normal, just set, the variable of a normal, instead of using a property, just set the variable directly, because then you don't have, it's 500 times slower using a property than just setting a variable. So that's a big, I see that sometimes. I've just done it myself with this voxel-based, system that I made for my terrain in my own game. So I figured that out in the hard way.
So
memory spikes, lag spikes, and weird stuff with when you're doing a lot of calculations at once.
I want to just, I feel obliged to say, if you have real-time lights in your VR,
Oh, yeah.
mobile VR, like turn them off. Turn it off. You're not getting real-time lights in the mobile VR. I'm sorry. And just, by the way, I mentioned the whole vert count thing in the presentation. Something I didn't talk about is if you have shadow casting real-time lights, those shadow casting is additional vert cost. And if you have two shadow casting lights overlapping each other, it's actually an exponential increase in vert costs. It's not like double, it's actually quadruple, I think, if there's two of them. And then times 8, times 16 if you have more.
Depends on the lighting model, but
Yeah, of course. But yeah, that's why, typically speaking, even today, like, if you have like a game level, even in like AAA settings, like with good hardware, you only have one main shadow casting light, and they're very clever about it. Like, you know, they'll swap them around and, you know, like do it very carefully, but it's a real performance killer.
That's true. It's extra passes as well in the shaders, so you're using one pass for drawing the actual geometry, and then you're using an extra pass for casting the shadows and everything, and so it is very expensive. Don't do that. You asked about some general optimization. What we generally see is that people try to build a level, and I just helped a small group like abroad making their first VR experience, and they basically put like the player into an extremely big city level, where they had every single skyscraper out in the distance modeled out and stuff like that. And what we usually tend to do in that case is, make the first in a radius, model the skyscrapers in some radius, but after that just make sprites, fake it until you make it in the end.
Okay. So it actually, it's kind of everything, and but what I'm hearing is, okay, there's a couple of things, like if you're already in a bad spot, right? It could be anything at this point because you haven't kept these things in mind. So you could try culling, you could try material pooling. You could try.
First thing is opening the profiler.
Open the prof. That's the first thing. So you want to open the profiler, and you want to understand like what's the distribution of like cost.
Not to keep going like the Spanish Inquisition on this, but like I think, and this is assuming initially that you understand the context and you understand the perspective and all that kind of stuff that was mentioned before. That's always the foundation point. So if say you just joined a project at the end, then it's like I'm getting told like time's up, but basically establish all that stuff first, and then then
open the profiler, see where you are and what happens, and if it's graphics, focus on graphics. If it's memory spikes, focus on where they are happening and why are you doing lists all the time or something. And if it's raw code, then you can go in and try and use some techniques to optimize the code, and that's probably the best thing, is to focus where it's worst first. That's the best advice I can give you.
That is good advice. Focus on the problems that you have. Focus on the problems in front of you.
The biggest problems first.
That's a good advice. I'm really happy to have had this chat with you guys. Thanks for taking the time, and
welcome.
Thanks to our guests online also for your interactions and your questions. I had a
really
good
good questions.
And I hope you had a good time as well. And I hope you have a great rest of your day.
Sounds good.
See you.
See you.
See you.